Law of signs to solve non-right triangles. So far in this unit we've solved right triangles, and we haven't talked about how to solve triangles that aren't right triangles, and that's what we're going to learn in this concept. Okay, first definition, law of signs. This is a formula to help us solve non-right triangles when certain information is known. The information that we would need to have would be either to have an angle-angle-side triangle, or an angle-side-angle triangle, or a side-side angle. Maybe these are words that you remember from geometry, but what they mean is that you have an angle, so I'm just going to make up angles, a 30 and a 50 degree angle, and then you know one of your sides. So this would be angle, angle, side. Or angle, side, angle would be maybe 30, 10, 50. So we know angle, side, angle. And then side, side angle could be like, we know that this is 10, we know this is 13, and we know that this is the angle 20. So it's side, side, angle. Really, for me, whenever I use this, I just look to make sure that I know two of the same letter. So I don't focus so much on knowing if I have an angle, angle, side, or an angle, side, angle, or a side, side, angle triangle. I focus more on, do I have what I need to fill in the formula? Okay, so here's our formula. I don't want you to use this one, so just cross that off. This is the one that I want you to use. Technically, we could use either one. They're the same thing, but I just want to focus on this one. So, you'll see that it has two equal signs and three parts. Well, we just pick the two parts that we want to use. So if we know about big A and little a, and big C and little c, then we just set those two equal. You won't ever set three things equal like this whenever we're using this formula. We're just going to pick what we need. And then over here we have this triangle that I've been talking to you about. Remember how I said that side B has to be across from angle B, side C across from angle C, side A across from angle A. I think I said that one backwards, but you get the picture. That has to be the case every time that you set up your triangles. Sometimes I will give you the triangle, sometimes you will have to draw your own triangle. But if you mess up setting up the triangle like this, then it's going to mess up the whole problem. Okay, here's our first example. In this case, we have a side angle-angle triangle, but again, I'm not going to focus too much on that. That's, by the way, the same thing as angle-angle side. All I'm going to look at is I'm going to say, do I know either both big A and little a, or big B and little c, or, I think I said that wrong. Do we know both big A and little a? Which is a no. I don't know either of them. Do we know both big B and little b? Yes, I do. So I'm definitely going to use B. And what are we solving for here? We're going to solve for every part. So let's start with big B and little b. And then I have to know one part of the other letters. So for example, I don't know any of my A's, so I'm not going to find A. I'm going to find little c. So we're going to use sine of B over little b equals sine of big C over little c. That's the equation that we're going to use. I'm not using A's here because I don't know either big A or little a. So let's fill in what we know. We should be left with only one variable. So we have sine of 25, because that's what angle B is labeled as, over 15, because that's what side B is labeled as, equals sine of 107 over little c. Okay, your favorite thing from 8th grade math was probably cross multiplying, which is what we're going to do here. So we're going to cross multiply in order to solve this. So I have c times sine of 25. So that's when I multiplied these two together. Equals 15 times sine of 107. By the way, we are not touching our calculator until the very last step. So don't even look at that. The last step here, I need to get c alone, so I'm going to get rid of the sine 25. So I'm going to divide both sides by sine of 25. And I'm left with c equals 15 times sine of 107 divided by sine of 25. So now we can put this in our calculator. And the way you're going to put it in is you're going to start with 15 times sine of 107. Make sure that 107 is in parentheses. And then you're going to do divided by sine of 25. In trig, we're always going to round to one decimal place, so the answer that I got for side C was 33.9. And I don't think I see any units on them, so we're just going to leave it as 33.9. Okay. Now we need to solve for angle A or side A. Angle A is going to be really easy because we can just do 180 minus 107 minus 25 because all three of those angles have to add up to 180. And I get 48 degrees. Now I need to find side A, and some of you might be thinking, Pythagorean theorem, but we can't do that because it's not a right triangle. So we're going to use, again, big B and little b, because we were given both of those parts, and we want to solve for A, so we're going to use the angle A and the side A. So the equation we're going to use is sine of big A over little a equals sine of big B over little c. Over little b. So we have sine of angle A is 48 over little a equals sine of B, so sine of 25, over little b, which is 15. Cross multiply. Then in order to get A alone, we're going to divide both sides by sine of 25. So we get A equals 15 times sine of 48 over sine of 25. So you're ready to put that in your calculator. And I get 26.4. Make sure that you round that 3 up because the 7 tells the 3 to round up. And now we have solved for every part of our triangle. So, recap. You cannot use Pythagorean theorem in this problem because you don't have a right triangle. And the first thing I looked for was what two parts did I know? And then I used sine of B each time to help me solve for parts of C and parts of A. Alright, this next problem looks a little weird because I don't see A, B, or C labeled in my triangle. I can label them wherever I want. It really doesn't matter. So I'm going to say that, let's go with 140 as B. So little b is across from big B. Let's go with C over here and little c over here. And angle A is 21 and angle A is also, or side A is 100. Okay, the first thing we need to do is we need to look and see, do I know both big A and little a? Or do I know both big B and little b? Or do I know both big C and little c? In this case, I know both big A and little a. So I'm going to use that to help me. The next part is, which one do I know half of? I don't know either of the C's. I don't know angle C. I don't know side C. So I'm not going to start with that. I'm going to start with B because I know angle B. So we have sine of A, sine of big A over little a, equals sine of big B over little b. So let's plug in what we know. Sine of 140 over, I messed that up. It doesn't matter, but I'm going to make sure I do it right. Sine of 21 over 100 equals sine of 140 over little b. Cross multiply. And we need to get b alone, so we're going to divide both sides by sine of 21. Now you can type that into your calculator. By the way, if you're not getting the same answers as me, there is a chance that your calculator could not be in the correct mode. So make sure you check and see if it's in degrees or radians. It should be in degrees. So for side B, I get 179.4. Okay, now I have both A and big A, little a, both big B, little b, and I'm ready to find big C and little c. Big C should be easy because we can just do 180 minus 140 minus 21, and we get 19 degrees. And now we just need to find side C. So I'm going to use side A again because I know both of those, they were given to me. So sine of 21 over side, which is 100, and then equals sine of 19 over little c. Cross multiply. And then to get c alone, we're going to divide by sine of 21. I get 90.8 for side C. If this gets a little messy labeling your triangles, you could come out here to the side and say, okay, angle C is 19 degrees, side C is 90.8, side B is 179.4. So you could write your answers in a nice little box out here to the side on your homework, if that kind of makes it a little bit easier to read. Okay, on our next one, they don't give us a triangle, they just give us the information for the triangle. So we need to draw our own triangle. It doesn't matter if you draw it, you know, which way you orientate it, it doesn't matter. I'm just going to draw one over here that looks like this, kind of looks like a right angle, but it's not. And then I'm going to label some sides. Let's call this one A. This angle is A, so this side is little a. We'll call this angle B, and so this side will be little b. And this one's C, and this one will be little c. We know that angle A is 115 degrees. I definitely did not draw my triangle right, but that's okay. And side A is 20, and side B is 11. All right, we need to first stop and think, what do I know both of? I don't know any part of C. I know both of my A's, and I only know half of B. So we're going to start with A's and B. So we have sine of A, which is 115, over little a, which is 20, equals sine of B, because we're solving for an angle this time, over 11. Always double check and make sure at this point that you only have one variable. So my only variable here is is my capital B. Alright, this is going to go about the same way, but we're going to have a little bit of a different ending to this problem because we're solving for an angle. So start by cross multiplying. We get 11 times sine of 115 equals 20 times sine of B. Okay, so again, we're still solving for B, so I need to get rid of the 20 first. I'm going to divide both sides by 20. Now, the way that we solve for angles, which we went over in the concept before, a couple before this, is we take sine inverse of both sides. I'm also going to flip it so that the B is on the left. So we're going to take sine inverse of this whole thing. Again, you should not have touched your calculator until the very end. So now we can put this in our calculator. So start with the sine inverse button, so second sine, And then in there, make sure you put every part in there carefully. And I get 29.89, and since we're rounding to one decimal place, that will become 29.9 degrees. Make sure that you put a degree on this because this is an angle, because it's capital B. So we have angle B is 29.9 degrees. Okay, next we need to find, well, at least one part of C, because we have to know one part of it. And I definitely can find my angle for C. I'm just going to take 180 minus 115 minus 29.9, and I get 35.1. Okay, the only part I have left to solve for is little c, so we're going to use our a's again because that was what we originally were given. Sine of 115 over little a, which is 20, equals sine of 35.1 over little c, which is what we're trying to find. All right, cross multiply. We're trying to solve for c, so to get c alone, we're going to divide both sides by sine of 115. Now we can put it in our calculator. We're not taking sine inverse on this part of the problem because I wasn't solving for an angle. Anytime you solve for an angle, you're going to use sine inverse. And I get side C to be 12.7. Okay, with this triangle, we need to label our A, B, and C again. So I'm going to label 63 degrees as C, so 44 would be side C. I'm going to put big A up here, so this is little a, and big B right here, so this is little b. I want you to now pause your video and try to work this one out on your own. Just a hint for you, you know both of your C's, so you're going to use that first. And you know part of B, so you're going to solve for sine of B first. So solve for big B, angle B. You will use sine inverse when solving for angle B. After that, figure out what this angle is, and then you can solve for little a last. Okay, so check your work with mine. I want to note down here for side A, I got 43.96. The 6 told the 9 to round up, and that's why I put 44, and you don't see a decimal on it.